Hello, everyone. Thank you for joining us today, and welcome to the AOF Edge webinar, where we invite AOF Edge community members and industry leaders to share production case studies, project demos, and latest updates from the AOF Edge project communities. My name is Sunny Tsai, and I'm going to be your host today. So for today's webinar, we have speakers from Linux Foundation Project Margo and AOF Edge Project Fledge to talk about open industrial automation framework and dive deep into how open collaboration can drive transformation across OT, IT, industrial IoT, and edge landscapes. So before I introduce our speakers today, I would like to remind you all that this is a live webinar, so feel free to drop your questions into the comment section. We will answer as many as we can throughout the webinar and during the Q&A section at the end. So joining us today, we have Arpit Joshipura, General Manager of Networking Edge and IoT at the Linux Foundation, Bart Nieuwborg, Governing Board Chair of Project Margo and Senior Program Manager at Rockwell Automation, and Tom Arthur, AOF Edge Governing Board Member and CEO at Dynamic. So without further ado, I will go ahead and turn the time over to the speakers to get us started.
Thank you, Sunny. So I will provide an overview for those of you who are not familiar with how Linux Foundation works and how projects are set up. I won't take long, and then I will introduce the market, the community, and then we'll go deep dive into two specific implementations or projects that enable the industrial automation space. So for those of you who are, it's rare, but I always find a couple who do not know what Linux Foundation does. So we are a nonprofit, and our goal is to create the largest collaborative framework that accelerate open source and open standards that will allow for faster and rapid innovation in markets such as the industrial edge. Okay? We are behind some of the most critical projects in the world, and our projects, we have over 1,000 projects, and we are organized either by a vertical industry or by a technology. And everything, from Linux, which is kind of the OS, all the way up and down the stack is what we have. And today we're going to talk about Edge, IoT, and more specifically, industrial edge. Now, the way we approach the solutions are through what is called vertical market adoption, and looking at it from an end-to-end perspective. So while each of these projects at the bottom, right, and these are just examples, take code, they take governance, and then they take solutions and testing to a specific use case and a specific solution, they all feed into some version of an enterprise solution or some version of a service provider, including cloud, or some type of end user environment. And specifically, when it comes to edge, we have very specific implementations, deployments, and use cases for each of these markets in this particular order. So what the best part of what we have seen is edge and IoT market adoption goes in a linearized, prioritized manner. Industrial manufacturing and automation is the #1 area where edge compute has really taken off, followed by energy, followed by retail, home, automotive, and others. So we're not going to talk about all of those markets right now, but focus on the industrial edge only. As far as LF Edge is concerned, we as a community have over 14, 15 projects. And the most important contribution of LF Edge started off with what is called terminology. Everybody gets confused. They start using the term cloud edge, near edge, thin edge, far edge, etc. And they're all relative terms. And so what the community did was, in a Wikipedia style definition, defined only two types of edges. There's a user edge and there's a service provider edge. User edge is under the control of a user and it's dedicated by them. Service provider edge is shared. And some sort of a last mile separates them. However, there is no one specific implementation of a user edge. And we feel there are three. There's a constrained device edge, which goes in microcontroller-based embedded compute. There's a IoT gateway type edge called smart device edge, and then there is an on-prem data center still in the control of a user. And then we have anything from radio base stations to central offices where they have edge computes deployed. And so if you take that dimension, and if you take the dimension of what I call vertical dimension of infrastructure to application, these projects on LF Edge are all set up in such a way that they unify these frameworks that go across the different markets of edge, right? So anything from a constrained device framework like a Fledge that we'll talk about today for the industrial applications, to an EdgeX Foundry, to anything that goes across the pipeline, or specifically solves the AI implementation problems on edge, right? Call Infinity Edge AI, or edge data problems in Edge Lake, or container deployments at scale for OpenEdge. So point being, we have a whole bunch of solutions, and we also have reports like State of the Edge that just got published for 2024. So if you have not taken a look at it, do download the State of the Edge report. I think Sunny can drop a link to downloading this report as well, which just came out yesterday. So that's the overview. Now let's go and look at Margo. And what Margo is doing is it is a very important project, because not all of the things can be done in open source software. We need specifications, we need standards, we need to seamlessly incorporate multi-vendor solutions, whether it's the applications that run inside the factory or the industrial floor, or the orchestration or the device management. So what we want to do is we want to sort of establish this project that, again, Bart will go into a lot more detail, that is complementary and allows us to specify with the end customer, the application, the manufacturers, to run various apps from various vendors and integrate these solutions and kind of do a POC so that the factories of the future can implement this vision. Okay. Now, with that said, it's important to understand where it fits in and how it fits in. And so LF Edge, while it's focusing on the broader open source projects, what Margo allows you to do is focus on the interoperable blue dots, right? Whether it's the registry and repository that comes with the apps and devices, the orchestration, the devices, and sort of specifies these interfaces, which allows the mix and match of orchestration devices as well as orchestration and devices, while creating the specifications and standards for doing one simple thing, which is edge interoperability. It's a critical aspect of the vision that we have. Okay, so with that said, I want to make sure that we have defined what the problem statement on industrial automation is, and then we will go into how we think we can solve it. So I'll take 2 more slides and then I'll hand it over to Bart. So for manufacturing and industrialization, we all know that we have been optimized for efficiency. And efficiency comes from consistency, standardization, simple supply chain, but most importantly, vertically integrated factory, which gives you the lowest cost, maximizes production, and very, very predictable output. And then you train your workforce to do one particular thing. The downside, very limited choices, very tough to change, and cannot take advantage of the latest and greatest innovation. So this is what we have been doing for decades, okay? And the new Industry 4.0, or whatever term you want to use, has been optimized for automation. It's been optimized for OT-IT convergence. It is optimized to allow the global community of partners and competitors to come together and solve what I call the common problems. Non-differentiated common problems do not need to be reinvented, and that's what Linux Foundation strives itself for, so that 80-90% of the problems don't need to be differentiated. And that's where open source shines. Okay. And then all of a sudden, these new technologies of AI, edge, compute, they all come into play, and they allow us to, integrate these things in this converged world. So it gives you flexibility, adaptability, and now you can have the whole global supply chain to help solve the automation problem. And then that's what the next decade looks like, right? This is not a 1 week, 2 week, 1 year kind of a movement. It's a full revolution. And we are really excited at the Linux Foundation to host these things. And if I then get to one click down on specific pain points, it translates to three big things. Workforce scarcity is the number one thing, because all of a sudden, if you want to innovate, new skills are required. And as I pointed out, that is not currently possible. And so translated skills that can be shared for the industrial automation market is a big requirement. And so that's one thing. You put more software at the edge. Now, all of a sudden, there is an edge to cloud connectivity. There's AI that comes in. A lot of the OT needs are changing because it could be disconnected. You could have high availability, things like that. And then all of a sudden, you want to have applications, compute devices, and data managed at the edge, right? So this is a new challenge for industrial manufacturers because they have not done these kind of life cycle management at scale. That is repeatable, that's automated. And then how do you take a solution and put it in production so that the factories don't get destroyed, right, with these new ideas? So POC to deployment at scale with all the vendors, right, which is the need for the future, is a wonderful problem that can be solved by the open global community of Linux Foundation. And that's what we are here to discuss. So I hope I have set up the problem statements properly. And with that said, I'm going to sort of go to the next section and introduce Bart, who will talk about, what we are doing in Margo for the interoperability aspects as it comes to specifications. So over to you, Bart.
Thanks, Arpit. Also, thanks, Sonny, for the great intro, setting up with an overview, and an answer to the question that Sonny rightfully mentioned: Can open collaboration be an answer for the industrial automation space? And that's the topic of this webinar. Can it work? And I want to give a kind of a testimony as being the chair of Margo, how this community is currently addressing a specific problem statement, if I can call it like that, that is currently active and present in the industrial automation space. And the Margo vision, Arpit gave already a brief intro. What is the vision that we are striving towards with the community? It is that apps from different vendors can run on devices from various vendors, that those devices can then welcome also any app that is Margo compliant together on those devices. But to those two pieces, they are then managed by what we call Margo compliant management solutions, sometimes referred to as orchestration tooling. But again, there have that freedom of choice for industrial manufacturers, those that are owning and running and operating industrial manufacturing plants, give them the freedom of choice to select the best in breed solution matching their particular problem space. That is what Margo is aiming for to address. And if we look at what we felt was necessary to have as key values in this initiative, openness, simplification, and scalability. And the openness, that is to give that ability to the users, the adopters, the industrial manufacturers, to have their freedom to choose for the best in breed solutions. Simplification, because we recognize that this industry is going to need to deploy at scale with the least resources possible. As Arpit was rightfully stating, workforce scarcity, skilled labor is a reality in industrial automation. The organizations that are active, the industrial manufacturers, have a real problem finding the right skill sets. And as Arpit was indicating, yes, smart software is a solution, but you're still going to have to manage now suddenly, instead of a set of workers that before were there to help you manufacture whatever you wanted to manufacture. Now you're going to have to manage also that install base at scale, that fleet of tooling, the software pieces, the workloads, and devices. Unless somebody can prove me the contrary, a software today still needs some compute surface to be executed on. That scalable and repeatable deployment and maintenance is going to be a key aspect that needs to be part of how Margo is going to propose a solution. Going a bit, or starting a bit, answering the question of, well, can it work for industrial automation or an open approach? Margo clearly took that decision to go for an open standards initiative, being royalty-free and open source, but at the same time allowing adopters, we call it suppliers, those that are bringing a for-profit or commercial solutions on the market that are having pieces of Margo in their offering. We found that allowing suppliers to differentiate their solution on top of the common building blocks is critical for the viability of what is being addressed with the solution. We felt that aiming for a single solution that would be open source, royalty free, that is not realistic. Nevertheless, addressing the enabling pieces of the solution stack is definitely an approach where multiple vendors, multiple end users found it as a vision to be working against. And what we found was API compatibility was the nice mechanism to have that boundary between enabling and differentiating pieces in the technology stack. A few other principles. Margo focuses on industrial automation. That's what the community wants to solve, the needs from that particular industry. It could be that what we come up with as solution stacks might be also applicable to other industries, but we felt like focusing on something very specific is important. Code first approach. Yes, we'll come on to that later. There are deliverables that we will work on, and that's not only going to be code, but definitely take a code first approach so that you can learn from those practical attempts of building the interoperability before you write the spec. Has to do with the experience that some of the founding members had in other, call it standardization initiatives over the past decades, where in some of those, people were writing during 7 years spec on paper before implementing it. By the time spec was written, it was outdated. That's what we want to avoid. What also we want to focus on, reuse of existing technologies. IT has been leading the way in certain ways of doing fleet management. We want to adopt it where possible, but adapt it so that it can be used in the OT space. And that, as opposed to having the OT community adapt the IT tooling, have to adapt the way they work. There are very specific ways industrial automation works and operates that has to be respected, because that makes what industrial automation is about. Abstraction is going to be key. That is how we feel that a solution that the Margo community will propose will be future-proof. Can move to the next one. Quickly restating and highlighting a few of those is, like mentioned already, not reinventing the wheel. But what does it then mean? How do you adapt IT tooling that you would find useful, like Kubernetes, OpenTelemetry, OCI container formats, and make it work for the OT space? Well, it means that the Margo community might be doing, where needed, upstream contributions to those mainstream open source projects that have already, since a few years, been addressing similar use cases or problem statements, not use cases, problem statements in different industries. Deliverables, and I saw it's one of the questions about, hey, when would things become available? We're going to focus on three main things. Open source reference implementation, that has as a purpose to demonstrate what Margo is about, to educate new members, adopters, how a Margo compliant device, a Margo compliant workload, a Margo compliant orchestrator could look like. We do have an open standard specification. It's going to be a written document, probably markdown language somewhere on the GitHub with a PDF printout if possible. And why is that important? Again, we believe strongly in freedom of implementation. Where needed, people can use pieces of the open source reference implementation that will be maintained by the Margo community, but we don't want to force everyone to adopt exactly those lines of codes. What is important is API interoperability. That can also be achieved by different ways of implementing what is sitting, what I would call, behind the API. And then the third pillar, a compliance testing toolkit, again available as an open source tooling. And that to, I would say, allow adopters for consistency in what they're doing. They want to test what they have been building and see, hey, does it work? The thing that I have been reading from the spec, now that I have built it, does it really deliver the interoperability? Point number one. But two, we want to do it in an open source and in a transparent manner, so that also the users, the industrial manufacturers that are going to make their selection of certain vendors that are going to deliver value, and at the same time mention they're going to be Margo compliant. So to make sure that there is a trust gained into the Margo interoperability story, meaning there will be, in a very transparent manner, all the test results will be published. That is the whole purpose of having the open source compliance testing toolkit. You will see that this is going to be very strongly related to the reference implementation. It might even be that the compliance testing toolkit is the reference implementation with some testing tooling around it so that you can prove compliance, etc. But the idea is there to, for adopters, facilitate the adoption. And for those that are going to then finally want to use those tools that all pretend and articulate, I am Margo compliant, that there's an easy way to go and check, hey, how does that team got his compliance? What we don't want in the compliance testing is that we would start creating bottlenecks like, I would say, testing or certification laboratories where it might work and might be required for physical devices. We know we are here in the software space. We're really looking into like modern tooling to do what I would call software-defined testing and compliance testing. There are technologies out in the space already adopted, I think, by Kubernetes. They are using similar ways of like publishing in a very transparent manner, having also the testing toolkit available in a very transparent manner. So it's a question that just is coming in, but I think I have answered it already. The vendors of the apps, they are going to be able to validate it against the specs. And that will be, again, those three deliverables is what the Margo community wants to build, but also maintain over time. As new spec versions come out, the tooling will get adapted. The reference implementation will be adapted so that it stays lockstep with the advancements of the specification. Where are we now? Well, Margo is very new. Margo started in April 2024. Since then, we have been growing, and the purpose is, or the objectives that we have, is that every 6 to 12 months we make tangible progress. The next focus is going to be to get a release 1 out. It might even be preceded by a pre-release to get already a feeling, or to give the world a feeling what are we focusing on in our first years. But definitely have that cadence of a reference implementation available, including the specification, including the compliance test platform. And then naturally, we will see adoption of the market, of the vendors that are going to come with first commercial offerings that are going to deliver that interoperability, allow the industrial manufacturers to have their freedom of choice. You can go to the next slide, Arpit. As an update, we started with 6 companies. We have grown now already our steering committee with 4 additional members. Also, we added some general and contributing members. In short, in 7 months, we grew faster than we actually expected. Anticipated, probably that we hoped, and we believe it has to do with maybe the simple, straightforward user story we are all working around, and that is if an industrial manufacturer wants to get his workforce scarcity addressed, he wants to go and digitalize his plant, it means he's going to have to go and look for apps for workloads that can solve his problem. He will, and that's a typical and a very natural and also the right approach that industrial manufacturers, I believe, should have, is that they want to go and test and validate and do that probably in a proof of concept setting. Once the value is proven, then they want to go and scale it. And then they want to go and scale it, knowing that their management platform, their orchestration platform, their device management platform, their observability platform might already be chosen company-wide, that the apps they find are very likely not going to come from the same vendor, and that the devices are also very likely not going to come from, I would say, the same vendors, meaning all those vendors have to find their story in this ecosystem. And in short, app developers, device manufacturers, simple. Build once, deploy many, whether it is hardware, whether it is software. And fleet management software vendors, orchestration software vendors, is manage the fleet regardless who is the vendor. That is going to be their objectives. And on top of that, aspiration related to Margo, they are going to compete. They're going to try to do it in the best user experience possible with their specific aspects to that. System integrators, machine builder, don't have to go in detail of that. I would rather spend a few minutes here on, well, what has the market been saying so far? We attempted to do our due diligence even before starting Margo. We wanted to verify, like, hey, surely we are some vendors that feel that this is an important topic to tackle, but what for us is more important, does the market thinks it's important? And the answer was yes on 2 aspects. First of all, yes, this is a problem that we have. This problem statement is real, that workforce scarcity is real. And yes, we believe that more smart software at the edge is a viable solution to solve it. But there is that need for interoperability, and that is not solved today. The second positive answer was, and yes, we do believe that open source as a framework is the right approach to get it solved. And I did not mention the company names, but you can see from the breadth of what I would call sub-industries in industrial automation, going from food processing through research, pharmaceutical, consumer goods, we had that good feeling that this was something we really wanted to launch and start. So what are we currently focusing on? There were some questions around that too. Focusing first on edge workload orchestration and associated observability, and we're going to focus in a second wave or in the second phase on device orchestration and device observability. And I want to mention immediately also, what is Margo not focusing on? Margo does not care what's inside the app. Margo does not care what is inside the device as capabilities and features, meaning it is not attempting to standardize on anything in there. We we consider really that getting the apps deployed and maintained at scale, including observability, that's where the enabling components of the solution stack are worth to be addressed in a joint, in a collaborative manner. The proposed system design here, that is there for your information. I'm not going to work through in the details, seeing the limited time we have here, but it will be there for those that are going to read it back. But I want to close out with kind of the answer to the question: Can open collaboration work for industrial automation? And I would say for the Margo community, the answer is absolutely yes. We do feel this is lowering the barrier for adoption of our solution. It is for those that are building that piece of the solution stack, the mutualization of the development efforts and the maintenance efforts are going to make us capable of bringing the solution faster to the market, but more important, make it a sustainable solution. We definitely did not want to do something like go fast, drop it out in the hands, and then stop supporting it. I mean, I saw questions about, hey, is there a schedule for long-time support, etc. Well, that is the reason why we feel that doing it through a community approach, there is for us a higher likelihood that this truly can be focused on those kind of needs for long-time support, etc. But I want to give also a few recommendations if there would be people here that say like, hey, interesting, I have also a problem I want to solve. I see my peers of me that feel the same. Could we go and use an open environment, an open source framework, an open standards framework like Linux Foundation? I would say yes, but clearly define your project scope. Clearly agree right from the get-go where is the delimitation between non-differentiating enabling parts and the differentiating parts. That is critical, because otherwise your community will start not getting the right traction, not the right alignment. Build tangible deliverables that are focused on facilitating adoption, but also facilitating trust. And definitely, I would say allow the adopters, those that are going to adopt the solution you're going to build, allow them to continue building and differentiating with their commercial solutions. We felt that is important because that kind of competition, because if you build commercial solutions, you try to differentiate, you are competing. That is the thing that industrial automation in particular was asking, because it fosters innovation. It allows the end users, the industrial manufacturers, to take advantage of the innovation that is the result of this competition. So that means try to find in your project the right balance between that implementation freedom and then, well, in the end, you want to ensure interoperability. A lot of open source standard project is about interoperability. You have to find the right middle way, and that can take a few discussions, I would say. What we have found in Margo, that the API approach was the most appropriate for our problem space. Can also be things like formats, data formats, but we felt like attempting to go too deep in the specification is often going to lead into challenges, and it's not going to foster innovation anymore. So leave that freedom with adopters. Think through that when you're coming up with the solution there. So I would say if people are interested, happy to welcome them, have a follow-up discussion if this particular problem space is something that's sensitive for you. But I'm going to give now, pass the ball, I would say, to Tom, who is going to give a bit of an update on his focus area.
Great. Thank you, Bart. Thank you, Sunny. Thank you, Arpit. And thank you, everyone, for joining us. And pretty much ditto everything Bart said, except Fledge, a project under LF Edge, is focused on the data path in industrial automation. So what we often find when we're talking to industrial opportunities is, what is the data path when you're talking to OT versus IT, and what is data management? So when you're involved with the data path, it really is about managing data. And especially in OT, where you begin managing your data, really matters. especially today in the world of data lakes and the cloud, where everyone's trying to get all the data in the cloud and then clean the data, curate the data, enable some BI report or some ML workload. There's completely different challenges in the OT environment when one's integrating with machines and sensors. So I apologize for a little bit of data management and data application overview, but this is generally a different conversation in OT worth talking about. So what do we mean by data management and data path? And going across the chevrons here, it begins with collecting and connecting to machines and sensors. And usually in the OT space, it's time series data. But more and more today, people are using higher fidelity sensors, accelerometers, cameras, array data, infrared cameras. So the data types are getting more diverse. They're getting more voluminous. They're getting higher fidelity to do ML workloads. And then, traditionally in OT, especially technologies like historians, so this isn't new to OT, you begin to transform that data, normalize that data. I need to put all that data into a common database. I need to organize the units. I need to make sure deduplication isn't happening and begin to organize it in a database. And then you begin after that contextualizing the data. Most of the input from, let's say, a PLC or a DCS, doesn't include the meta information about the data. You don't know what factory or what machines are behind that. You just know temperature. You may not even know temperature. It may just be a value 36, and is that Celsius or Fahrenheit? So you begin to contextualize that data. And from there, using really the terminology of a Snowflake or a Databricks, you then curate that data once it gets into a cloud. So in the speak of Databricks, ultimately creating that golden table where the data is completely cleaned and now ready for the ultimate BI report or data science ML AI workload. Now that I have my data managed from a machine or sensor, you need to write applications for that data. And so in the case of OT, some of those applications, if not most, absolutely can execute in the cloud. But in OT, many systems are always going to be on-prem, whether MES systems or OE systems or historians. So some of those applications are obviously on-prem and happening there, which one could call the edge. But ultimately, especially with higher fidelity data, many applications for intelligent automation need to execute much closer to the data sources, the machines themselves. So that is the data management data path challenge go back to one slide. Arpit. So that's data management. In OT, the data, though, is very, very different than you find typically in IT. And probably the biggest challenge you find in the OT world is what I call the brownfield, greenfield integration. And many new technologies like MQTT, Sparkplug, or OPC-UA talk about it being the new protocol that will solve the brownfield, greenfield problem. But the fact is, in OT, it's a problem that will last forever. And the reason this brownfield, greenfield challenge, which goes down to data management, will last forever is, let's say I'm in the energy business and I need to buy some transformers that go in my substation. This piece of capital equipment is going to last 30, 40 years, but it comes with some compute. But the lifespan of that compute system, as that everybody knows, is 3 to 4 years. So, year 5 through year 40, your compute is out of date from modern compute for a transformer that needs to last 35 more years. So there is an OT data challenge in making your data management work on new machines as well as old machines and legacy machines, and that problem lasts forever. So data management in OT requires one abstracts data and data management from the machines and the integrations themselves, which is what Project Fledge is all about. Other nuances in the OT is you're usually dealing with millions of real-time streams of data. You're dealing with unstructured data. You're dealing with literally, I'm new to OT in the last half a dozen years. There's well over 120 different types of protocols across process and discrete manufacturing that many of you have never heard of. I certainly haven't. Data definitions of machines. There's no standardization for a data definition of, let's say, a pump coming from 5 different manufacturers. I've talked about high fidelity data. Another very unique requirement in the data path with machines is set point control. Ultimately, you're going to want to be able to write back to a machine, maybe to affect a change if you're building some intelligent automation application. Often in OT, your connections themselves are unreliable. They're remote. They're in a mine. They're out in a remote mine where maybe I'm using Wi-Fi or even older technologies to reach my equipment. So the OT data challenge, especially around data pipelines, is different and very complex. Next slide. So in OT, then there's a whole nother set of discussions around the application space that are worth noting. I'm down on the new use cases under must have. So there's a whole new talk about semantic models or digital twins. And so the concept, of course, is I have a model, a computer model of how a machine operates, or I'm creating a semantic model of, let's say, a transformer with 61850. These types of technologies must have an intelligent edge to actually execute. How am I going to take a digital twin, which will describe this pump in detail? It'll talk about how it operates. It'll talk about the tags that stream from it. It'll talk about the rates of the interactions between the machines and its components. All of that data, all of that context needs to be translated in a data pipeline as you integrate that data with clouds and your on-prem systems. All of that requiring then an intelligent edge. And then, of course, the ultimate vision for machines of tomorrow is really the self-driving car. So if you have the idea of a machine that is out remote, it's pretty obvious that you have high fidelity sensors and all that operating on this machine, controlling this machine. You're not going to send all of your data into the cloud to decide whether do I hit the brakes or not on the car at the stoplight. So similarly, as you introduce higher fidelity data, different types of data to operate the next level of an intelligent machine, you need the ability to do some of your processing and transformation at the machine edge. These are the types of applications that Fledge is designed to use. So if we kind of come back to, in the OT world, the automation pyramid, which is really the description of data management in OT since really 1980. If you look at the left side, most people think about simply collecting data as good enough. If you have 120 different protocols out in the world of machines and discrete and process manufacturing, how do I take those 120 protocols and translate it maybe to a OPCDA or OPCUA or an MQTT? Or if I'm a major hyperscaler cloud provider, how do I translate all those protocols to get it into my particular cloud? So I call that data collecting, and that is the old 1980 Purdue model way of thinking about data management in OT. But instead, we've developed Project Fledge to enable these new types of workloads on machines. So focusing on the data management and the data pipelines. That means the ability to do exactly what data collecting is: collect from any machine, integrate that data, and send it to a destination like the cloud. But not only that, be able to process, transform, and integrate that data with multiple destinations, the operational systems of OT, as well as the cloud, as well as data science, and include the ability to do write backs all the way back to the machine when one needs to do a set point control. So we would call that data management in Project Fledge. And actually, Arpit, you got the next slide? I think I have the architecture slide. No, okay. So go back to, I wanted to put in the architecture slide, but it's not here. So I'll try to describe the architecture of Project Fledge in this slide. Project Fledge is a set of 6 microservices that run in Linux. They can run in bare metal. It can run in any virtual machine, or it can be containerized. So hence, obviously, we are making sure that Project Fledge can run in Margo once that orchestration mechanism works. But it can work in Kubernetes today. It can work with Project Eve today, and be deployed anywhere that one can run microservices. So it can be deployed on something as small as a Raspberry Pi Zero. It could be deployed on-prem in a well-provisioned container, or even in the cloud as a container. It has 6 microservices that are designed first. We have one called the South to collect and connect data from any data source. And in the architecture, it has a concept called a plugin, which is an opportunity that our community is working on all over the place. And I'll talk about a success story here with RTE.
Hey, Tom,
Yep.
give it 1 second. I think
Yep.
we
Do you have the slide?
Yeah, we'll probably flip that in. So
maybe
Sunny,
we can come back to the architecture slide.
Yeah,
It
no.
really
Sunny,
is, I think, the meat of
this
special.
is the best part of being live, right? Just making sure that. Okay.
There we go. Okay. So here's the opportunities and where the community is really focused in Project Fledge, and this is the architecture. As you can see here, there's 6 microservices. Those are the 6 blue boxes you see here. The blue box on the bottom, called the South Service, is written in C, and these blue boxes we call plugins. And this is a plugin is the idea that you can write a little piece of code in Python and or C and add that easily where all the other microservices will simply work. So as an engineer, you can focus on the problem at hand. So starting with the South Service, for instance, with over 120 different protocols in discrete and process manufacturing, we certainly don't have them all done today. So instead of writing an entire edge technology for some new protocol, you can simply write in Python a protocol connector, the blue box, and that then will integrate to that device. So then once we collect with that protocol, we can then do basic filtering in the South Service, as you see there. You can see here, you might be doing an ML workload, or you might be doing filtering data, or you might be doing something like signal processing. Project Fledge supports, for instance, accelerometer data. So maybe you're getting raw vibration data, and before passing that on to the cloud, you might be doing signal processing, RMS and FFT calculations. And then the South microservice collects the data, and then we transform that data into a common JSON format in the storage service where Postgres or SQLite run. And those two are pluggable databases. So Project Fledge then can buffer that data if this is remote, making sure you don't lose it, formatting the data from the South into a common JSON. And then it passes through the REST API to the third microservice, the North, which then integrates that data with one or multiple destinations. And as you can see in the architecture, it's a mirror image of the South, where you use the plugin architecture, once again, where you can write your own Python or C code and integrate that data, the streaming data, with any destination. So any cloud, any operational system into data science. And once again, you see you can then filter that data as you egress it out of your Edge Fledge deployment. So you might be doing things like compression as you send the data. You might be doing condition forwarding, only send this data if and when this condition exists. And then the fourth microservice has set point control. So Fledge you can write applications that will write back to a machine. And those commands can come from something in the North, from the cloud, from an operational system, or from Fledge itself. So you can do a set point or a control back down to your PLC to actually control some automation system or machine. The fifth microservice in Fledge is the event notification service. And so you can write any application that will analyze the data and send that data and send a report or send a set point control. And last but not least is the orchestration. So how does one actually manage a Fledge? How do you do security? How do you do updates? How do you do user management? How do you do security and scheduling? All of that then is used to control your Fledge, all through a shared and open REST API. So Fledge is designed to create intelligent data pipelines from any source to any destination and write these new advanced edge applications in an OT environment. Next slide. So just quickly, Fledge is a stage 3 project with LF Edge. That means it is deployed in the field and ready to be used. Project Fledge is over 6 years old. And I've got 2 use cases I want to talk about next to really demonstrate how Fledge is being used today in the field. So next slide. Before I go there, just a little bit on what is Fledge, Fledge Power, and FogLamp, because this will be important to understand in the next 2 use cases I'll show. So Project Fledge is everything I just talked about. The Linux Foundation has another umbrella group called LF Energy, which is a series of energy companies and energy suppliers focused on specifically green energy opportunities in the marketplace. So Fledge has been adopted by LF Energy, with a special set of plugins, which is what the community is building specifically for the energy market. Most of that work has been done by RTE and Oleander. RTE, which is the use case I'll show here in a second, is the grid operator for France. So as a community member, they wrote the IEC 104, TASE 2, 61850 protocol plugins, as you saw in the architecture, and contributed them to the community. They've also written, as you'll see in the use case I show up, a converter of set point controls from their new control center down to their older brownfield equipment in substations. And then going over to the right, there are 3 different companies today who have adopted Fledge and offer commercial support. So you can get, if you're an OT company and you want commercial support, you can get that from Aviva, Aviva Schneider. You can get that from Fleur, an infrared company, and you can also get support from my company, Dynamic. Next slide. So here's the RTE use case. RTE, as I said, operates the grid for France, which is over 3,200 substations. Next slide. The problem RTE has is one that pretty much every industrial company on planet Earth has, and that is the brownfield, greenfield equipment problem. In RTE's case, they have substations, these 2,600 substations, where about 600 of them use an old protocol called TASE 2. Another set of 500 substations use a proprietary protocol called HNZ. They have their newest substations use 61850. Some other substations use IEC 104. So these are what the protocols supported for controlling their grid use out in the field. But then they bring in a new data center with a new control center for that grid from Hitachi that uses OPC UA and 61850. So the problem they have is, how do I have my new data center have a multi-protocol capability to use these new protocols, OPC UA and 61850, to actually monitor the data and control my IEC 104 RTUs out in the field? So let's just call this using Fledge for a multi-protocol gateway to and from their control center to their substations. That's a very typical use case for Fledge today. Next one. And I'm short on time. So this is a deployment done with Aviva out in the field with Archer Daniel Midland. And this is a talk really about how sophisticated applications can get in Fledge. So this is actually intelligent automation on a centrifuge using Fledge to optimize the use of a centrifuge that is used to purify food oil that you buy at the grocery store. So the last stage of food oil production is this real-time, or it's not a batch oriented, it's a flow of, in this case, rapeseed oil going into a centrifuge, where out the middle, you get your fine oil that you buy at the grocery store at about 30 degrees on the centrifuge. You get a food thickener called lecithin, and out the edge, the oil's been emulsified with water, and so you get the water and the particles out. So the problem at ADM was how to optimize the centrifuge and prevent a situation called a breakover, where a centrifuge is no longer separating the light oil from the lecithin from the water. So using MLAI and Fledge, they've solved that problem. Next slide. Basically, they say here it works, and they're surprised. And then the next slide, talking now, and this is just typical. I want to talk more about just data pipelines is really the takeaway for this slide. So how does the requirement in creating these advanced applications, which is the opportunity for everyone in the community commercially to build on top of Fledge, is they needed to connect to the PLC. In this case, it's Ethernet IP. They put 4 accelerometers on the exact same centrifuge. And so the first problem is, I need to collect vibration data knowing the state of the machine. So at 200 RPMs, it vibrates like this. At 400 RPMs, it vibrates like this. When the oil is XYZ temperature that has this % water, it vibrates like this. And so by being able to combine these complex data pipelines, send that to data science, ADM and Aviva were able to build a machine learning model that successfully predicted breakovers 3 minutes before they occurred, and integrate all those results to the HMI of choice at Archer Daniel Midland using Fledge. So those are the kinds of applications that are complex and the type of data pipelines, and you can see the reasons why you need to compute on the edge. And last slide. So I guess in summary, Margo allows any app to run on any hardware. And what we're doing with Project Fledge is through data pipeline, intelligent data pipelines, allowing any app to use any data source with any data destination to run edge applications. Thank you.
Awesome. Thank you, Tom. And that was a great presentation on Fledge and Margo as well. We did receive 2 questions that we haven't addressed yet. That might be more for you, Bart. And then one question we have is, how do you perceive the distinctions or relations between Margo orchestration and OPA orchestration?
Okay, well, a great question. Now, as always with acronyms, they can mean different things. OPA could mean as well open policy agent, as it could maybe be the open process automation orchestration. I'm just going to go for the last one because I think that has most to do with it. Orchestration of an open policy agent. Definitely, it is related to the Margo problem space, and it is, for example, one of the, what I would say, existing open source projects we're looking at to see, hey, can that be adopted related to policy management? But I think the question is maybe more around, hey, how does it relate to the orchestration approach the open process automation forum is focusing on? I would say orchestration is orchestration, but it depends what you're orchestrating. With Margo, as I indicated, we stay away from what is inside the business logic. Whereas, and in that way, I would say we are complementary with what OPAF is focusing on. That is going one level deeper, but in a very particular industry, the process industry. So it might not be as broad as possible there.
Yeah, and I will add, Bart, on that. So it is a CNCF project on generic policy. So, yes, absolutely worth a look. I would also point out that we have a project called Eve, which is built-in orchestrator for the edge under LF Edge. We will have one of the future webinars on that as well, as it gets kind of optimized, beyond and outside the scope of Margo, but interoperable with the full end-to-end stack. So that's good. I think we may be out of time, Sunny. So you want to wrap with the last 2 slides?
Yeah, absolutely. All right. Before we wrap it up, I just want to let everyone know that so getting involved in LF Edge community is open to everyone, and it's the best way to learn and contribute to the future of edge computing. Here is a quick step-by-step guide on how you can get started. And also, if your organization is ready to lead in edge computing, consider joining LF Edge as a member. Membership offers opportunity to influence projects, connect with industry leaders, and shape the future of edge ecosystem. All right, I think that's all we have today. And thank you all to our awesome speakers today. I appreciate you all joining us. And also thank you to everyone from the audience who has been participating. If you would like to stay connected for our next webinar, please follow us on LinkedIn, X, as we will announce the next webinar topics there. Thanks again, and see everyone soon.
Thank you.
Thank you. Bye-bye, everyone.